Alright, so in this podcast we are covering the last two gas laws, and the first of those is known as Dalton's law. Alright, and Dalton's law is known as the law of partial pressures. Alright, and it basically says that the pressure of a gas, or the pressure of a gas mixture, okay, mixture just means more than one thing are there, but the pressure of a gas mixture is simply the sum of the gases that make it up. Alright, it's usually written like this, kind of as an equation, but pressure total equals the pressure of our first gas plus the pressure of our second gas plus the pressure of our third gas plus dot dot dot. Okay, so we can have several different gases. Maybe if we think about air is made up of oxygen and nitrogen and argon and carbon dioxide, stuff like that. So we might say if oxygen equals 1.2 atmospheres and nitrogen equals 4.5 atmospheres and carbon dioxide equals 0.5 atmospheres, what is the pressure of the mixture? Alright? And in this case, we want to know the total pressure. Alright? So we're really solving for P total. So simply we're going to put X, because that's our unknown, is equal to our first gas, which is oxygen, so 1.2 atmospheres, plus 4.5 atmospheres, plus 0.5 atmospheres. Alright, if we take 1.2 plus 4.5 plus 5, that doesn't really look like 4.5. I'll erase that real quick. Alright, so if we have 1.2 plus 4.5 plus 5, that is going to equal 6.2 atmospheres. Okay? And it's pretty much as simple as I can ask you a question like that, or I might say the total pressure is, and we know this gas, this gas, and this gas, what is this last gas? And then you're simply going to put your total pressure equals whatever, plus X, and just solve for X. Okay? So that is Dalton's law. And then the last law is known as Graham's law. In Graham's law, has to do with, so up here we might define Dalton's law as partial pressure. Alright? So it always has to do with pressure, and if we add up the partials we get the whole, or we get the total. So always parts combined to get total. So partial pressure just means parts. Graham's law has to do with effusion and diffusion. Alright, and these two things really relate to how fast gases move. Diffusion is if someone walks into a room and they have maybe some perfume or cologne on and they stand right at the door, who is going to smell them first? If the room's crowded with people, the people closest to them, because those gas molecules are going to leave their skin and go into the air, and then they're going to diffuse from where it's really concentrated, maybe a neck or a wrist, to where it's less concentrated. So they're going to start spreading out, and the person closest to that person will smell it first, and finally the entire room, because it's a gas, will smell it, but it won't be until the very furthest person from them. So why do gases diffuse quickly or slowly? Alright? And this essentially boils down to this point. The smaller the gas, and by smaller we mean little molar masses. Alright, so these are the masses we get from the periodic table. Little molar mass is what we mean by small gases. So small gases are fast movers. Alright, so the lighter the gas, the faster the gas. So if a gas is light, it's going to move more quickly. If a gas is heavier, it's going to move more slowly. So if we just do a couple examples, or just compare two things, let's say we had carbon dioxide and nitrogen. Okay, so we're going to get the molar masses of both these molecules. So carbon dioxide is basically 12.011 is carbon's mass, and they're going to multiply two oxygens, which are 15.999, and when we add those up, we're going to get, I don't think I can necessarily do this in my head, we're going to see 9, from there comes that, that's probably going to go up to that, we had, it's that or pretty close to that, okay, grams. Nitrogen, on the other hand, is just 2 times 14.007. So when we add that up, we get 28.014 grams. Alright, so if we have these two that we're comparing, it's as simple as which of these is lighter. The nitrogen is lighter. So if the question asks which of these will diffuse quicker, the nitrogen will diffuse quicker. How come? Because it's lighter, alright, and it can just move faster. And that is it for the last two gas laws.